Hello and welcome to my animations project. Right here you can see I'm showing that I know how to work with animations, how to make a run, and with the IK handlers. As you can see, the foot there is adjusting to the terrain. And then if I run, I've got the movement of turning linked to my mouse. So as you can see, I'm sprinting and it's running as I control my mouse towards the X and along the the X of the mouse controls, and as you can see here, WS and D goes strafing, going forwards, go backwards. Oh, bit of a bump in the train there. There you go. And running. Yeah. So let's get into the code. In this project, I will show you how I've been able to go on the internet and find paid assets and also free assets from such websites as like the Unity app or, for example, Mixamo. Sorry if I say that name wrong of the company, but I think it's called Mixamo. And also textures as well. You can get textures from there, and I have other websites as well that I can get paid or free textures. Unity's Animator, along with the base layer of the Animator, using it for simple animations, or the blend tree for more complex animations. My first project using this is my first project using inverse kinematics, otherwise known as IKs or IK handlers. So if you hear me from now on saying it as IK or IK handlers, I mean inverse kinematics. This allows me to get a good grasp on how IKs work and their purpose and how to implement them into a proper humanoid avatar. So let's get straight into the player controller script. As you can see here, this is my URLs where I keep all my globals. I try and keep them all neat and tidy to where either I know them, I know where everything is, or if someone were to come in and read this, I just try to keep it as tidy as possible so that it's easy to see. So yeah, I can see here I'm using the rigid body, my camera, which is from the main camera. Let's dive in. So the new movement function. This is compared to the input manager I've got in my other scripts. This one I've created myself because I figured if I ever wanted to kind of customize it the way I wanted it to, and not just with WS and D, it's just a lot easier, I feel, to do it this way. So if I ever want to put like Q and E to make maybe strafing that way instead of pressing just W and A or W and D, then I can. Next down here, you can see I'm using my animator variable to gain access to my animator's set float parameters, which I'll show you in the animator parameters and further details in a bit. On line 71 here, you can see I'm accessing the string name of that said parameters from the animator, which I'll show in a sec, and the different directions and animations I require. So as you can see, the direction of X and the time.delta function. I'll get into that in a sec. Along with the obviously, as you can see, this is the dampening. So it's like smooths out the animation, and to which we use time.delta time times 2. We are using time.delta time here to help the animation compare the system's internal clock to the system's time. So when the game engine starts processing the previous frame to the time the system started processing the current frame. So it just makes that time in between a lot smaller in numbers, so it makes it a lot quicker. So yeah, it just basically makes the movement and the animation a constant speed, no matter like kind of the frame rate, keeping the FPS numbers to like 0.1 to 1 FPS. Increasing it's just like smoothly highs, and the higher frame rate the game is, the smoother it will run at. On line 73, I'm accessing a separate layer of the parameters for reasons I shall explain in a bit when we get to the animator blend trees. As you can see here, it's like the running value and it's getting the mouse X from the input manager. That was the where I was moving the mouse left and right on the X axis. Y is the mouse controlling the direction of the sprinting, but I just thought that I would just be a bit different and give it a go and see how it felt when I was like moving the mouse for the camera to move the player as well, just to see if I could do it. As you can see down here on line 75, I've got vector 3 velocity direction equals new vector 3. Allow me to put the input of the directions I require into the vectors of x and y. So movement direction here, so the direction of which I want them to go into. Using this, we can then take the vector and use it to convert it into the transform direction to the world space on line 77 here. So take the vector velocity we've got there coming from the movement, and we'll put it into the transform of our player and the direction, and we'll put that into our variable here. This helps me know the correct way the player is facing in the game world, instead of just like the local directions of the player. It'll be for the world direction as well. On line 79 here is the if grounded, checking the player is grounded. This is a raycast I'm creating below, and I'll show quickly just here. It's down here in this raycast. It's just shooting down from our player's position, going from the minus transform up, so that's obviously down. It's just a small ray, just to check if that ray is touching the ground, and if so, then we can use it up here. So if we are grounded, then we're going to be wanting to give our rigid body the velocity and the speed that we have set. It's a public float, so I am able just to give my player as much speed as I want in the inspector, rather than doing it in the code, so it just saves me having to flip between the two. Also, by using the grounded function, I can check whether or not to give the player a directional velocity, and if not, then apply the gravity along with it, so that we fall with gravity of a natural force. Let's move on to the mouse look function. In this function, I'm getting the x and y values of the from the input manager get axes raw, then changing the player's transform.Euler to the Euler angles to the Euler angles I want with the y vector using our x value from above, so that I can change it with our mouse input of the x value to rotate our main camera. And as you can see here with the x and y, and then with Euler angles equals to the transform Euler angles plus vector up. So because obviously that's the mouse of the Euler angles I want. Below here, I am just clamping our Y local position to keep the camera on the Y's rotation we are using above. So we want to look up and down. It does so in a linear up and down motion to the player's local position, though, that is. And then the line above, just setting our camera to our target's local position with our camera attached in the hierarchy already attached to the player. I have its position, the distance for the offset manually. Last, I'm making sure the camera is looking towards our player at all times. Here is the IK handler script. In the script, I am using the inverse kinematics, or IKs again, to take the avatar of our player model to gain access to its rig, which is the skeleton of the animation, of the avatar. And with that, I'm going to access the player's feet to show that I can move them around and adjust them to the environment. The onAnimator IK function here, in the script function, I am assigning the right foot and the left foot to the animator within the animator parameters we have created, which I will show in the animator tab. Then I am assigning the animation of each foot to the skeleton, and also assigning them to have the weight and position. So here's the position, circle position of the right foot with the weight, and the set position of the position, but this is set position like weight. Right here we're getting the foot and we're assigning it to the parameter from our animation. Then down below here you can see I'm assigning the rotational weight I want of the right foot and the rotation itself of the right foot as well. And we're doing the same here for the left foot. It's pretty much the exact same, just obviously for the left foot. Now I shall quickly show you in the Animation tab what I was talking about. Here is the X and Y value of which we were using before for our mouse. This is the isGrounded parameter for our animator. It was just a boolean because obviously if it's happening then yes, because I do have a falling animation, but I did not really put a ramp in or anything to test that. But it is in there, but I didn't think it was super important. It was just something I messed around with. Here we have the running X value. We have the right foot weight and the left foot weight of the animator parameters. If we go into the blend tree here, you can see how I set it up on a 2D freeform directional. This makes it just easier to map out the controls and how the animator is going to flow between each of the animation motions. So we have the walking backwards, the idle. Your idle is always going to be the 0, 0, because it's going to be in the middle when your character is stationary, and all the other animations are going to revolve around that being the center pretty much. The further out ones are going to be the diagonal, and the ones strictly to the left and right are going to be the just going left, right, forward, backwards. If we go out here to the base layer, this is the simplest form of the animator. We can go into the running tree here. I separated the running tree just to make it not as busy in the this is the walking animation, like strafing as well, which is why if I go into here, these are the strafing. So if I click on these, it will highlight the two. Well, it highlights them. There you go, highlight them. So if I go back, go to the running tree here. So blend tree. This one I kept it at one dimensional because of it's just running between two types. You've got the normal running forward and the right turn and the left turn. As you can see here, it's got the threshold of 0, -1, and 1, because that's the one it's going to be switching between. 0 being the normal, as normal is going to be just running straight. Down below here, because we're using the get foot hit in the parameters before we are setting the IK positions and weight of our feet. If it equals to true, which means, as I'll explain down here, if this function down here, get foot grounded hit, equals to true, then it will start assigning those left foot and right foot IK handlers. That the IK handler will start setting up calling this function. So down here we're checking, getting the reference of the feet, its rotation, and then its positioning, and then I'm checking if the ray, which is very small, is hitting anything, so that I can know whether the feet should be checking for an incline or not on the obviously being the ground. And this is obviously coming from the transform. The transform up. This is coming from the transform up, and the transform minus transform up, which is down, obviously. I just set it to green, sort of green, and with a size of 2. This is just so I could debug and see what was going on in the scene. Here, with the ray being sent out, is obviously getting from the animation and the get IK position of our foot. The raycast being sent out with the hit, as you can see with the hit reference. We are getting the hit point of the vector of where it is hitting. And then with that transform.up, because obviously I wanted the feet really just to be taken into account that the feet are going to be going up on the incline, because I haven't put a ramp in this one. so it's going to be making the foot elevate upwards. And I did dot normal because it's going to return us the angle of that incline, and it will give us that perfect angle to which the foot should be facing up towards, which is the foot rotation of the quaternion, look duration, and it's going to be obviously transformed forward. I want the feet to be inclining upwards, but like make sure they keep forward and not they won't rotate like around to the incline, but they will naturally go upwards as your feet normally would without breaking an ankle or anything, and using that hit dot normal like I discussed earlier. And yeah, that was my animation project, just to show I can use animations and IK handlers to work with feet on incline. As you can see, yeah, see the leg working as well. Thank you very much.